Okay, in this video, we're going to go over some factoring problems. Now here is factoring where a is 1. Okay, a is the coefficient of the squared term. Okay, that's also known as easy factoring. So in order to do easy factoring, you're going to say the following to yourself. What two numbers multiply to negative 20 and add to negative 8. So think about negative 20, and I'm thinking I can have 10 and 2, and if my 10 is negative and my 2 is positive, that's going to do it. With easy factoring, you go directly into x minus 10, x plus 2. Okay, you are done at that point. Factoring just means leave it in factored form. Okay, we're going to jump around. I'm going to do the next one. I'm going to eventually do this with a graphing calculator, but I want to make sure you have the fundamentals of your factoring before I do that. Okay, next problem. This says my function is x squared plus 10x plus 16. So what multiplies to 16 and adds to 10? So 8 and 2 come to mind. Notice they're both positive. That's going to work out just fine. So I can directly go into my factors. Done. You can always FOIL this to make sure you're correct. Multiplying the first, I get x squared. Multiplying the outers, I get negative 2x. Multiplying the inners, I get negative 8x. And multiplying the lasts, I get positive 16. If I add negative 2x and negative 8x, I get positive 10x, and I'm sorry, good thing I checked it because look, they're both positive. I get positive 10x and I'm good, and then plus 16, everything checks. Okay, you can do the same thing with the first problem, and I'm going to leave that to you to do. Okay, I can see right away I'm going to get negative 20. I can see I'm going to get negative 8. I see I get it, but make sure that number 1 checks out for you, because you can easily make a mistake, and you can easily fix that mistake. Okay, the next one, also easy factoring because the coefficient of the x squared is 1. So with the easy factoring, you're going to say what multiplies to negative 12 and adds to negative 1. So I know right away it's negative 3 and, negative 4 and positive 3. So that's going to give me x minus 4, x plus 3, and we're done. Okay, next one. Do not let this style fool you. It's still a quadratic. So your first step is to write it like that. So now this is your f of x. I want to factor this. What multiplies to 9 and adds to 6, and that's going to be 3 and 3. So this one's going to be x plus 3 and x plus 3 again, and we're done. Okay, so you should absolutely know how to do this. It's an Algebra 1 skill, it's an Algebra 2 skill, it's a pre-calculus skill, and it certainly is a calculus and college algebra skill. Okay, next set of problems. We're going to factor these, and this is a situation where the a is not equal to 1. So if the a is not equal to 1, you're going to decompose. You're always going to decompose this middle term. Okay? So let's see if we can get going. When you do this, it is critically important that you say to yourself, what multiplies to 2 times negative 21? That is negative 42. And adds to negative 11. Okay, so I want you just to think about that for a second. Okay, so what two numbers do this? It's going to be, let me come back over here, 14 and negative 3. No, negative 14 and positive 3. Okay, that will work. So I'm going to decompose. I'm going to rewrite this piece. I have minus 14x plus 3x minus 21. Okay, underline your first pair, underline your second pair, leaving a gap in between where that positive operation lies. Factor out what they have in common in the first pair, bring down the operation, copy the parens you just wrote, and now figure out what number goes here. That number is going to be 3. Okay, let me make some more room for myself. So I'm going to move that out of the way because we know what we just did. Your factors in this case are 2x plus 3. So I grabbed the 2x here. I grabbed this operation and I grabbed the 3. And then my other factor is the x minus 7 that appeared twice. Those are my factors. If you FOIL that, you'll get back question number 5. Okay, let's look at our next one, number 6. And this is also a hard factoring, and I know that because the 9 is present and it's not a 1. So that's your A. Your A is not equal to 1. So you're going to say to yourself, what two numbers multiply to 90, so that's 9 times 10, and add to 21. So think about that for a second and see if you can get those two numbers. So you should pause the video. So you can figure out a couple of things. It's not 30 times 3, but it is going to be 15 times 6, and they're both going to be positive. So I get the following 4 terms. This is plus 15x plus 6 plus 10, 6x, excuse me, plus 10. Underline the first pair. Give yourself a gap. This is a plus operation. Underline the second pair. In the first pair, what do they have in common? Pull out a 3x. You're going to get x plus 5. Bring down the operation. Give yourself a little gap. And this, I'm sorry, is going to be 3x plus 5. That's 3x plus 5. What goes in front to make the 6x plus 2 reappear? 6x plus 10 reappear? That would be a 2. Okay, what are my factors? 3x plus 2, those are all the outside terms, and then 3x plus 5. If you FOIL that, you'll see that you have the correct factorization. Okay, that brings us down to the next problem, number 7. First thing you're going to do is you're going to rewrite that so that you are recognizing that it is indeed a quadratic situation. This is now your f of x. To factor that, you're going to say what multiplies to not negative 6, but negative 6 times 2, which is negative 12, and adds to negative 11. Okay, so that you should get as negative 12 and positive 1. Decomposition is our mission. 2x squared minus 12x plus 1x minus 6. Underline the first pair. Give yourself a little gap. Underline the second pair. Pull out what they have in common in the first pairing. Bring down the operation. Copy the parentheses. Figure out what goes in front to make positive 1x minus 6 come back. That would be a 1. Your factors are 2x plus 1 and x minus 6. Okay, you have to know this. It's not an optional thing. Okay, last one on this page. First step, rewrite it so that you see it is indeed a quadratic. Watch the sign of that 5. This is your f of x. Ask yourself what multiplies to a negative 10 and adds to a 3. That would be what? Positive 5 and negative 2. Decomposition is our mission. 2x squared plus 5x minus 2x minus 5. Underline your first pair. Give yourself a space. Underline the second pair. What do the first pair have in common? They have in common only an x. Pull out the x, and you get back 2x plus 5. Write down the operation. Duplicate the parens. And figure out what goes here to get back a negative 2x minus 5. And if I put a 1 here, that will do it. Okay, what are my factors? X minus 1, close parens, 2x plus 5. If you FOIL it, you'll see you have the same thing back. Okay, so hopefully you got to see all of that. I'm going to make this smaller. There you go. So in case you just heard it and didn't see a component, it is all there for you right now. Okay, so that's how you do that work. Again, you've got to know how to do this by hand. We also mentioned this year that I'd like to be able to have you do things using the graphing calculator, and I asked you to get one. So what I've done here is I've written out all kinds of steps to take. So I'm going to do these steps, and I'm going to do it on the following equation. Okay, I'm going to do this on y equals x squared minus 3x plus 4. So I'm going to kind of walk through it. What I'm going to do is I'm going to switch screens so that you can see my graphing calculator. And then I will talk it through. And your job is to make sure that you understand what I'm doing, because you are looking at your own graphing calculator. Okay? They're going to assume that you know how to do this in college. So let's practice doing it now. Okay, next thing. I'm going to switch screens. So I'm going to stop sharing this screen. And I'm going to pull up the graphing calculator. So let me do that in just a sec. You should be getting your graphing calculator in the meantime. So I'm saying share screen. I want to share my desktop. And I'm going to pull up the TI-84. So let me just do that. And then you should be able to see it on this screen. Okay. So this is what I want you to be able to see. Let me make everything a little bit bigger here. And let me just get this to go out a little bit more. Okay. So that should pretty much do it. I don't know if I can make this go any bigger. You don't really need to see my keystroke so much as you need to see the keys. Okay. So I had said that I want the equation that we're testing to be x squared minus 3x plus 4. So go into your y equals. You see where that is? It looks like that when you hit it. And I'm going to type in x. I'm going to square that x. You see where I just hit? So I have x squared. And then it's going to be minus. Here's your minus. Okay, this is a negative, not a minus. So I want a minus. So minus 3x, here's a 3, here's my x, that key, and then plus 4. Okay, so I have now typed the equation in my y equals. I'm now going to hit graph. Okay, so I hit graph, and that is my function. Now look, what are you seeing? This function does not cross the x-axis. what if I didn't like this particular window? What would I do? Well, I could go into window, so see where window is? And let's say that this is really a lot of blank material that's not helping me. So I don't really want that. So I'm going to go into window, and you see how it goes from negative 10 to 10, a scale of 1, and negative 10 to 10. Also a scale of 1 and a resolution of 1. So this is called a standard window. I don't need the Y min to be down that far. What if I made the Y min, I changed it, so I have to go down on my calculator like this, and I'm going to make that number. How about just making it a negative? Look what the negative is right here, a negative 1. Then I hit enter, it records it, and I'm going to go back to graph, and look how my window has changed. So you have to be the master of your window. Okay, so finding the roots, well, I can't do the roots on this one, so I'll have to do it on another one because I don't have roots that cross here. But to do that, I would have done second calc, and I would have looked for the zeros, which is equivalent to the roots. Let's skip that for a second, and let's look for the y-intercept. So I'm going to go into value instead, so I'm going to select the 1. Okay, they say x is some value. Well, what is x? On the y-intercept, x is 0. Boom. Put the 0 in, hit enter. Look what it did. It identified the y-intercept as the coordinate pair 0, 4. That's your y-intercept. It matches the y in the B position. Okay, next I want to find the vertex. I'm going to go back to second calc, and I know it's going to be a minimum because I looked at the shape. Here's a minimum. I need to find that vertex. I'm going to say, let's see, it says left bound. Left bound says, is the cursor to the left of the lowest point? It is. So I don't have to move it. Okay, I could move it like this to get closer if I want to, but that would be optional. I'm going to now hit enter. Now it says get the right bound. You need to get to the right of your vertex. So let's go this way, go all the way around. The second you turn the corner, you can hit enter. Boom. And it says guess. It's not really guessing, it's going to approximate. And here is your minimum. 1.5, if I round to the nearest tenth, comma, 1.8. That's your minimum. I could have gotten that by doing negative b over 2a, but I'm using technology to get this. Okay, what if I wanted to view the t-table? The t-table I can view by saying second table. Look what I have. I have all the coordinate pairs. Isn't that wonderful? So those are my coordinate pairs. Now, what if I wanted to see a different view of that window? What if I wanted to start at 2 instead? I could say second, this is table set. See where it's above? Table set. And I could start instead at 2 and still go up by 1s. Hit enter. Okay, tell it you want the table again. Where's table? Look up here. It's above graph, so I'm going to hit second, graph, and now my table starts at 2. Okay, so we have several different things that we've discovered here. Okay, let's do another equation. So I'm turning over to number 9 now that you've gone and seen this one time. Go into your y equals. I already had this value, or this equation. I no longer want that. I'm going to say clear. It's gone. Type in what you have in number 9, which is x squared, remember here's where the squared is, plus 5x minus 14. I'm just going to peek at that graph and see what that looks like. I'm going to go to graph. Okay, oh dear, I seem to be missing some of the graph. I need to see down further. That's not a problem because I'm going to go into window. I need to see more of the negative. So let me come down and we're going to do some trial and error. So this is negative 10. Let's hit graph. Oh, didn't quite do it. We need a bigger number. So go to window once more. Go to window. And I'm going to make this is only my only problem is this. Why not make that negative 20? And then hit graph. Almost. Oh, look how close I am. Okay, so since I'm so close, when I go to window, I'm going to hit, and it's just this one that's a problem, child, right? So come over here and make that negative, 26. Hit enter. Now hit graph. Ooh, much better. So what am I seeing? I have roots, also called x-intercepts, also called the zeros of the function. I have a y-intercept, and I have a vertex. I asked you to first find the roots. We didn't do that last time, so let's do that now. So I'm going to say second calc. Let me do it again. Sometimes, you have to kind of play with it. Second calc. I want the zeros, which is number 2. Hit enter. Okay, it's going to say left bound and right bound again, but I need to get to the left bound of this root. So let's move this around. So I'm hitting, you see what button I'm hitting? Move it around and get it above your vertex. Hit enter. Now they want right bound. Get it below your vertex. Hit enter. Boom. Hit guess. Here is your y-intercept. -7. Your x-intercept. -7, 0. That is your coordinate pair of that first root of the equation. Let's find the second one. Go back into second calc. Go back to 0 once more. It says left bound. I want to be down here. So I'm going to come around. Once I'm below but near the root, I hit enter. Then it changes to right bound. I'm going to continue above. Once I'm above, I hit enter. It says guess. It's really calculating. That's my second root at the coordinate pair of 2, 0. Okay, the next thing I want is the y-intercept. It's right here. You're going to say second calc again. Now I want a value. Remember, at the y-intercept, x is 0. I just put it in a 0. I hit enter, and bingo, there's my y-intercept at the coordinate pair 0, -14. Next, I want the vertex. Guess where we're going? Back to second calc. And I want to figure out the vertex. I see it's a minimum. So I'm going to go down to 3 and hit enter. I have to be left bound. Move the cursor around the vertex. Once I'm above the lowest point and I'm to the left of it, hit enter. Then it wants right bound, come around the other side. Once I'm above the vertex to the right, I hit enter again. They want to guess. I say go. Here is your minimum. You can see you have some approximation, going here. If you just took it to the nearest tenth, it would be -2.5, -20.3. Okay, that would be your coordinate pair. It says use the calculator table, identify 3 points. What are those 3 points? Let's see. How am I going to find them? I'm going to go to second table. I didn't limit what kind of points you're going to get. You can take any 3 pair and put them on that table. Know that you can change this table around by using the second table set. Second table set. You can reformat it. You can start at 0, for example. You can go up. This says change in table. If you wanted to, you could go up by 2s. So let me get to that number. If I hit 2 and I say second table, look what's happening. My x's are changing by 2s. Okay, so be the master of that table. That covers number 9. Let's go to number 10. So I'm going to go back up here. Remember, I no longer want this equation. I'm going to come over here and say clear. Now I'm going to type in 9x squared minus 3x minus 2. Okay, I'm going to graph that little puppy. And that's not bad, but really, do I need to have all of this blank, all of this blank, and all of this blank? So I'm going to do my table again. I'm going to say, I'm going to do my graph again, my window. I'm going to say window, and I'm going to, I'm losing my head. I am going to say, I'm going to say window without hitting the second. I want window. I don't want the x quite so negative. So how about I make that just a -5? And could I delete? Yeah, a number. I don't have to. It's already there. I don't want it so wide either. Make that a 5, and that's good. Come down here. What else did I discover? I don't think I needed it quite so low. So let's make that a -10. And we can always come back and fine tune it if we need to. Okay, so let's go back and look at the graph and see what we think. That looks better, and really I could have even gone and cut this further if I wanted to, but I don't need to. Okay, let's do the following. Find the roots. Second calc, I'm finding the roots, which are the zeros of the function. Go to 2. I'm going to do left bound to find that root. So come on over. Once you're above the axis, you can hit enter. Then move the cursor below the axis, but near that root. Hit enter again, and hit enter, and that's your approximation. So that's -1/3. Okay? So let's find the other root, which is here. And I'm going to say second trace, which gives me calc. And I want to have the 0. And I'm going to move my cursor so that it's under here. Hit enter. Move it one more place. Hit enter. And then guess. And that's my second one. This is +2/3, comma 0. Next, you want the y-intercept. To get the y-intercept, I'm also going to go back to second calc. The y-intercept I get by saying value. And I tell it the x is 0. I hit enter. Here's your y-intercept, 0, -2, and it's showing me where it is. Lastly, we're going to do the vertex. Second calc. It's a minimum. I have to recognize that first. Come down to minimum, hit enter. Put your cursor to the left of the minimum. That's to the left. Put it to the right of the minimum. Hit enter twice, and that is your minimum. You can round that appropriately. Next, it says use the calculator table, identify 3 points. Again, second table. Here it is going by 2s. If I want to change that, I go to second table set. Let's go by 1s this time. And I'm going to start at -6 and say enter. Got that. I want to go to second graph, which gives me table, and here I have my new changed table. Okay, so that's how you use a graphing calculator. You absolutely want to go through this and try this on your calculator. You just watching me is not going to be sufficient. Well, I hope you found this helpful. So I'm going to stop the video now. Thank you very much.